What is Aurora? That's what you're here to find out, right? It's an exciting new technology that FlexRadio has released into their product line, appropriately called the Aurora. And well, you'll have to watch the video to find out. Now, it's a few days before Hamvention 2025, and I am under non disclosure along with George from Ham Radio Workbench Podcast and a number of the guys from the YouTubers bunch, whom I'm all sure you will all recognize. And we were pre disclosed on this, and it is being released on time, on schedule for Hamvention 2025. So I hope you enjoy this rare behind the scenes look with Steve Hicks, the CTO of FlexRadio, and Mike Walker, and take a look and enjoy.
I'm gonna walk you through some kind of strange material here as a lead up, so you understand kind of where we're going here. This is going to seem really odd as I start down the road here, but what we measure as S units are a change in power level in our radio, and each S unit requires an additional 6 dB of power, which is 4 times the power. The difference in 80 and 120 watts of power is only 1.7 dB, or less than a third of an S unit. So it's not uncommon to hear people say, well, I only have 80 watts on this band, but really the difference in that and 100 is not a whole lot. It's around a dB. Each S unit costs more than the last to produce. So if I have a milliwatt and I want to go to 100 milliwatts, that's 20 dB, or roughly 3 S units, and I can accomplish that with a $5 part. If I want to go from 100 watts to 10 kilowatts, that's also 20 dB, but it requires a $200,000 amplifier. So that's just kind of level set everybody here. So if we talk about being on HF and receiving a signal at the noise floor, let's say it's S1. These are what the S1 signal would be in terms of decibels with respect to a milliwatt. It'd be minus 121, or it's 0.8 femtowatts. And I have a thing down there to show you what a femtowatt looks like. And to get from S1 to S2 or S2 to S3, it's 6 dB of power. So if we assume we have a 100-watt station and our contact can hear us at S1, that means there's 171 dB of path loss. And I just took the S1 number I had back before and took plus 50 dBm and added the two of those together and got 171 dB. So how would our signal be received if we had more power? Well, if we went from 100 to 500 watts, that's 7 dB, and so that's a little more than an S unit. If we go all the way to 1500 watts or legal limit, that's 62 dBm, or it's only 5 dB more. In other words, 500 watts is actually more than halfway to 1500 watts. And it's kind of counterintuitive. People think that's a third of 1500 watts, and in terms of power it is, but it does make a big difference in how your signal's received. If I also talk about rejecting heat from an existing transceiver, we typically put 250 watts roughly of DC into a 100-watt HF transceiver. We generate 100 watts of RF and 150 watts of heat. So your HF transceiver is typically much better at generating heat than it is at generating RF. This is at 40% efficiency, and sometimes you can be a little more efficient than that, but 40 is kind of a rough number. So if you wanted to get from 100 watts to, say, 500 watts or 1500 watts, let's talk about how you do that. So today, if you have a flex radio and an external power supply, you've got roughly 16 pounds of equipment. You have to put 250 watts of DC power or AC power into it. You generate 150 watts of heat, and you get 100 watts out of RF. So looking at other solutions, if we went to 500 watts, today you'd buy an external 500 watt PA. You'd typically buy a 500 watt antenna tuner, and you'd add all that stuff up, and it's roughly 47 pounds using stuff that's readily available on the market. So you triple your weight. You'd put 1,350 watts of input power in, generate 800 watts of heat in order to get the 500 watts out. And if we'd go another step up and look at 1,500 watts, there's a similar thing, and you actually generate around 1,800 watts of heat, which is why we have these huge fans on our 1500 watt amplifiers and all that. And that kind of gives you an idea for the pricing and all the other kind of stuff. At 1500 watts, you generally need 240 volts as well. So just to look at what it takes for us to reject heat, we have a heat sink in our radios, as does everybody. And this is what our heat sink looks like in a Flex 6000 or 8000. It's this aluminum extruded heat sink that takes up this bottom area in the radio. If I look at our 1500 watt amplifier, this heat sink's capable of rejecting 2 kilowatts, and it looks like this. And the thing weighs quite a bit. It's the full length of the radio. Here it is in a side view as well. So a lot of what we have to do in high power RF is to reject heat. So typically an HF power amplifier is only 40, maybe 60% efficient. And in a 1500 watt amplifier, the heat generated is around that of a household hairdryer or a portable room heater. Heat rejection is the key reason for the size, weight, noise, and cost of an amplifier. If you go look at what all is in that amplifier, the fact that you're terribly inefficient means that you have to reject all that heat. That adds extra weight. You have an extra large power supply to generate all that heat, all the other stuff that goes with it. So let's say hypothetically we wanted to put 500 watts of power into a radio, put it in one box. So we'd need a 500 watt PA, we'd need a 500 watt antenna tuner. We might even put our power supply inside that. And so the question is, if we did all that, what would that radio weigh, and what would it cost, and how much heat would you have to reject? So there are folks that have done this at 200 watts to get you half an S unit, and this is the kind of weight that these things are. You've probably looked at these radios and know, what they cost and what they weigh and all that. And I'm not poking fun at any particular manufacturer here. This is how it's done. You want 200 watts, it takes the extra weight and extra power supplies and all that stuff to make it happen. So we have a solution to all this, and it's called Aurora. And you might have seen we ran a teaser ad on in several magazines, including QST. So it is the first significant advancement in transmitter technology since the 1970s. So we're producing an HF transceiver that has an integrated 500 watt transmitter. And so instead of being 40 to 60% efficient, it's 80 to 90% efficient. And what we have in the radio is not a power amplifier. It is a standalone, and so it can't be used as a standalone amplifier. It's actually a transmitter that has to be integrated into the exciter. And with that efficiency, we have less power input required. That means there's less heat to reject, which means a smaller heat sink, which means less weight in a smaller box, all those kind of things that go with it. And the military calls this low swap, for low size, weight, and power. So this is the 500 watt transmitter stack from an Aurora box. And it uses the same size as the 100 watt PA that we have in the radio today, and the same 100 watt heatsink. So we're going to offer it in two versions. There's what we call a non-M, which doesn't have the display and the knobs on the front of it. It'll look like this. And the M models will have they look just like the M model radios we produce today, and they'll have an Aurora splash screen on them. So to go compare this against, the other solution I showed you, which was buying a 500 watt PA and a tuner, instead of 47 pounds, this unit's 18 pounds. So it's only 1.3 times the weight of a 100 watt radio. And it's considerably cheaper than what it would cost you to put all those pieces together. And it's also completely integrated. So you buy one box, the box is in the same size as our Flex 6000 and 8000s, but it's a 500 watt radio, and it plugs in directly to AC power. So you don't need an external power supply for it. Okay, so this is our word problem for you today. If a ham with a 40% efficient 500 watt radio generates 800 watts of transmitter heat, how much heat does his friend with an 80% efficient 500 watt transmitter generate? Anybody want to guess?
It's a 40% efficient. How much heat does it?
I mean, most people would guess that because your efficiency has been doubled, that you would use half of the power generated in heat. But the percentage is misleading, and what actually happens is you only generate 125 watts of heat, the way that it works out. And so that's a 2-scale graph on the left of what it would take you using today's MOS and LD MOS technology to generate 500 watts of RF with 800 watts of heat, compared to Aurora, which only generates 125 watts of heat out of a 500 watt transmitter. So as I mentioned, it is a transmitter, not an amplifier. You can't use it as an amplifier for any existing RF devices. It has to be tightly coupled to the generation of transmit signals. So it is going to be, therefore, a FlexRadio only technology, and we're not going to offer it as an amplifier for use with a third-party exciter, because we really can't. We'd have to ask those guys that design the exciters or the low-level power transmitter to redesign that. It is worth mentioning that it is more sensitive to the load impedance. So power fallback begins at 1.7 to 1 today. We may loosen that somewhat in the future, but as a result of that, we don't want this to be used without an antenna tuner. So we integrate an ATU into every Aurora radio. So it has a 500 watt antenna tuner inside.
Nice.
So these are the four models that we're going to have. There's they all start with AU. So with one SCU, it's an AU 510 as a non-M, and then you put the M panel on, it's an AU 510M. And then with two SCUs, it's an AU 520 and an AU 520M. Incidentally, this only makes 200 watts on 6 meters. So it's 500 watts on HF and 200 on 6. So if we look at the use cases for this, obviously the home station is one. You can plug it directly into 110 to 240 volts. It's got everything you need inside it. It's a very modest station, a small box, but it gives you 500 watts of power. So that's a wonderful thing to have. If you don't have to have all these extra boxes, and it takes up a lot less space, and you don't have the cable clutter and all that sort of stuff. For portable, it's terrific because you minimize the teardown and setup of any kind of portable station, and you've got a huge punch that you wouldn't have any other way without bringing all this other equipment. It also has a huge weight advantage. So, you can throw this in the back of your car without having all the extra boxes. And it does run on reduced power for operations involving limited AC. So if you're using a generator, you're going to use about half of the generator fuel, and you need half the size of generator that you would have if you were going to do 500 watts on any other radio. All that same stuff goes into the DX. So if you're doing this on a DXpedition, it's the same kind of thing. But DXpeditions are really going to love this because the logistics of carrying the power out to a DXpedition location are really a huge part of the cost and inconvenience and everything, the planning that goes into it. So here you can literally carry on a 500 watt station, take it out somewhere and use it, and use significantly less generator power and fuel. And then, of course, remote is another option. So if you have a remote station, you can put it out somewhere. It's only one box. You don't have to worry about all the integration pieces and making sure each one turns on at the right time and all the other stuff. You just have the Aurora box turned on. You signal to it that you want it to come on, and then operate it. And it's also a lower investment cost. We do mention some non-use cases. One of these is out-of-band operation. So this radio does not have any ability to transmit out of band. So if somebody wants to use it for Mars or Civil Air Patrol or shares or any of those kind of things, it does not work in those areas. So this is one of the things that had to be done in order to get this technology to market, is we concentrated just on the amateur bands the way it works. And so there's no open the box up and cut the green wire and it works or anything like that. It physically will not do it. There's also the idea of using this with an amplifier. So can you hook this to a 1500 watt amplifier? Well, you could, but we're going to say it's not recommended because 500 watts would typically destroy the input of most amplifiers, and all it takes is one mistake to blow it up. So while you can do it and it would work, you'd have to turn the power down to 50 watts or whatever for most 1500 watt amplifiers. And if you make a mistake, you're going to ruin your amplifier. Okay, so that's it. Now, how do I make this thing stop presenting?
I'll get rid of it for you.
There we go.
That's
all right.
Interesting.
Questions, comments?
Well, yeah, I got a question that goes with a comment. So I noticed on your table it was a 5.2 amp draw to get 500 watts out. Can you still feed it DC, or does it expect an AC feed then? Because it sounds like there's a power supply included or internal, right?
There is an integrated, well, there's actually 3 integrated AC to DC power supplies in the box. It only runs off AC. So if you wanted to use it with DC, you'd have to have an inverter to use it.
You have to have an inverter, which is fine, but a 5 amp draw to get 500 watts out that's pretty good.
Yeah.
That's insane.
It needs roughly 650 to 700 watts, just depending on what else going on. So
okay, so it does have a high draw. Okay, yeah.
What is the power foldback at 1.7 to 1? What's it? Is it going to fold back half, quarter? What is going to fold back to?
You know, I don't remember exactly how we have it set up today. It begins folding back and continues as the SWR goes up, but I just don't remember what it is, what the algorithm is off the top of my head.
Okay.
And I believe we'll loosen that some over time. I don't know for sure exactly when or how much, but that's where it is today.
Gotcha. Yeah, we've got some Yagis that are on that threshold.
But you've got a tuner built in.
You have an integrated tuner to deal with that, but
yeah, I don't like to use a tuner. So
no, I don't blame you. Does it when you say it draws 5.2 amps at 500 watts, are you talking about? I mean, what's the duty cycle? I guess is my question. Are you talking about sideband CW FT8? What are you going to do over there?
Do you have that picture?
Yeah, let me bring that up real quick. I got a picture I'll show you.
Let's come back to that question, Jason, because
Okay.
Anybody else?
While we're looking for that photo, what's the range on that built-in tuner? Is that the kind of industry standard 3-to-1, or is it a wide-ranging tuner?
It's a pretty typical tuner, so it'll do 3-to-1 around the circle, and if you have a more resistive load, it'll do better than that. But we're saying it's a 3-to-1 tuner.
All right.
So Steve, you mentioned that conventional radios using LDMOS transistors these days. What is this radio using?
We're using, I don't think we're going to talk about exactly what we're using in here, but we're using, they are transistors, but they're a very different kind of transistor. So I don't know. We may eventually talk about what the technology involves, but I think today we've said we're not going to spend a bunch of time talking about it. I know that's weird, but.
So you're going to,
you know what? I might have that picture. Oops.
So you're going to offer. You're going to offer 4 solutions, one with the Maestro included on the front panel, one without, and then one with 2 slices and one with 4 slices. Did I see that right?
Yes.
Okay, gotcha.
A 2-slice and a 4-slice, each with a Maestro and without.
Right.
The
4 solutions.
And the 4-slice model is still two antenna feeds.
Yes.
4 slices, but 2 feeds.
And
yes,
that's same as
If
before.
it follows the older models, then yeah.
And then also the 2 slice is going to have 1 SDU, and the 4 slice will have 2 SDUs.
Correct.
Comparable. It's like comparing a 6400 to a 6600.
Yes.
Yeah. And then what about contest filters? Are you going to have contest grade filters in any of the units?
Yes, the 520 has contest grade filters in it.
Gotcha. Okay.
Now, Vince doesn't know about multiflex because he's never used one of our radios. So multiflex is the ability for 2 clients, and it doesn't matter what they are, to use the same radio at the same time anywhere in the radio spectrum. You just sort of fight over the transmitter. Only one guy can transmit at a time, but the change happens in milliseconds.
Yeah, 2-op single radio built in.
Can you see the picture I'm sharing?
No, sir.
Hang on a second. I've got to see it pop up. Is it this one? I didn't. Yeah. Hang on. I've got to wait for the thumbnail to load. And since I have 2 blank Steve Hicks, let me add this to stage and see what happens. Nope. Let me add this to stage.
That's the wrong one. It's there you go. There you go.
There you go. That's the one. I was guessing.
So in this picture, on the left is a radio. This is sitting on the bench in our lab. In the middle is a dummy load, and then right to the right of it, we've got a CW key with a brick on it.
There you go.
I wondered what the brick was doing.
And I got a picture here I took with a thermal camera, and you can see my load is really hot. It's 91C, and that's a nice 500 watt bird load. And this has been running like this for 2 hours when I took this picture. And
Oh, wow.
the radio, you go put your hand on the radio, and it's literally cold.
That's pretty incredible.
It's like it was 33 degrees C when I pointed the camera at it. But yeah, it's cold.
That's crazy.
So this is gonna run this with your regular Smart SDR. It's gonna integrate just like we're used to with Smart SDR. The only thing that's gonna be different is we're gonna have a fader that says 500 watts of power at the end of it, right?
That's right.
Wow.
What about existing customers, Steve? Is there an upgrade path for those that just bought into the 8600 architecture?
I'll answer
that's
that.
a sales question.
That's a sales question.
Not at this time. Not at this time. We'll review it as we see fit. But this is going to be for this radio. You're gonna have to sell it on your own, type of thing.
When's this going to be available?
Yeah, that's my next question.
So
When
you answer it, Mike? I don't care. You can answer it.
Okay, I'll let sales answer it. Target is first customer ship in 2025. So we're hoping early Q4, late Q3, but there's always, as we know, little hiccups that might go long.
So are you taking orders at Dayton?
And we'll be taking orders at Dayton. We already have a number of them made. They've already been in use, and some have been in contests. So with pretty good results, actually. So
cool.
Do you have a hands-on unit to show people at Dayton?
Yes,
we'll
sir.
have 4 units at Dayton. Yeah.
Awesome.
So, Steve, this is pretty unconventional. So I imagine that you guys have been thinking about and working on this kind of an idea for quite some time. Could you comment on the design process? What how long has this been going on, and how challenging was it? I mean, this is a pretty amazing platform.
Yeah. So actually, the technology that we're using was proposed in 1945, I think, but none of the components were around to make it actually work. And so about 10 years ago, Tony, K1KP, began looking into this after he retired from a job working at HP for years. And he messed around with this for about 4 years. And then in 2019, sent, I believe, multiple manufacturers a note asking if they had any interest in this technology. And he actually got a vendor booth at Dayton. And I went over and saw Tony and talked to him and looked at what he had, and it wasn't ready for prime time, but it had a lot of promise. And so I talked to Tony. We flew Tony into Austin. He lives in Massachusetts. We flew him into Austin, and he brought a prototype. We did some testing on it and talked to him, and said we'd like to bring it to market, which is what he really wanted to happen. And so we've been working with Tony for the last 6 years to make this technology mature and bring it out on a radio. And it's really, of all the things that we've brought to market, this is one of the most complex. And it doesn't really seem like that on the surface, but there's a lot to it to make it work well. So we spent a lot of time. I don't know how many iterations of boards and stuff we went through to bring this to market, but it's a lot of work.
Is the challenge in the electrical design, or is it in the software controlling the transmitted envelope, or what?
It's all
servoing and the PA.
It's all of those things. This uses. In fact, you can go. Tony has a website where he explains, and he did a QEX article. I don't know what it was, 6-7 years ago, on kind of the basics of the technology. But it uses polar modulation, and so there's a lot of things because of the way that it works, getting everything to align and the electronics to work and stuff. And there's just a lot to it.
So
you can go to his website at qrz.com, Kilo 1 Kilo Papa, and then there's a link to his story on that.
So going back to the
Go ahead,
portable operation for a second, you had the picnic table and all that set up. So is it pretty much assuming you have to give it mains power? It's expecting 120 volts, or depending on which region you're in?
Yeah, it'll need 120 or 240 if you're in Europe or whatever. But yeah, it'll need mains power. There is no DC power input on the radio.
Sure, but those are the voltages, the two voltages you're expecting, somewhere 120 and 240.
So the internal power supplies work from 80 to 264 volts.
And I'm assuming if you give it 80, you're not going to get 500. You're going to get something less, or how's that work?
No, you can give it 80, but you got to give it 80 at, whatever it happens to be, 8 amps or whatever.
Right. Okay. So the 5.2 amps was at 120, or was that 240? Okay.
Steve, was there any testing done? So we're assuming here good, clean sine wave energy. Was any testing done with modified square wave or anything like that, which might be typical for use, battery inverter, some generators?
Oh, I see what you're saying. We have not done that testing, no. I don't. That's a good idea. Hadn't done any of that, so don't know how it would respond. For modified sine wave inverters, I don't know.
Okay. I think that's a really interesting point, because for portable operating, that's probably a super important.
Well, and some of the generators are sine wave, air quotes, but they're not great sine wave generators, right? They're inverted sine wave.
And even if they're sine wave, sometimes they're not very
clean.
Controlled frequencies.
Right.
Yeah, so frequency controlled. Yeah.
And you're talking about generator. I mean, you can do a gasoline, of course. I think you're talking about gasoline generators, but
sure.
What about running it on like an EcoFlow or something?
Yeah.
So I'd be
so we haven't done that. Now, one of our alpha testers has run it on a generator, I believe. I don't know for sure. I'd have to go ask, but that is an interesting question. I don't know. Now, I will tell you that the power supplies inside, we did not design. They are commercial power supplies, and they're, like 10th generation power supplies. But they're well designed, but I don't know how they'll respond to modified sine wave. Don't know.
So, Steve, how efficient are the supplies if you're running lower power? Let's say instead of 500 watts, you're running 100 watts to compare it to a conventional 100 watt radio. Do you know what the power consumption's like at a lower output power?
So it's similar. The way that we built the internal power for it is that we reduce the voltage based on how much power you need. And if you get below a certain threshold, we actually can turn off one of the internal power supplies and do some stuff like that. So we've done a bunch of stuff to try and keep the efficiency high. The worst case efficiency that I've ever seen that I can recall is like 78, but in general, it's going to be above 80.
Okay, so back to the topic of operating portable. If you said, well, for field day, we're running 100 watts, unless we really need it, then we're going to, raise the power for a little bit. Even at a lower power, it sounds like it's relatively efficient.
I believe so. I haven't personally taken measurements on it. I'd have to go ask one of the engineers, but I don't remember how efficient it would be, but I'd be shocked if it's any worse than 70.
Well, that's good for all those field day tent operators who bring along an air conditioner. They won't need as big a one.
Yeah, true. Right.
Yeah.
So it sounds like from a customer point of view that initially when I went listening to your description, it sounded like, well, the integration of everything would certainly sort of obviously would be nice, because you don't have to have 4 boxes and cables and all that. But it didn't really occur to me till you brought up the heat generated, and let alone just the electrical consumption efficiency is really improved. So for a lot of folks who don't have a big radio room, if you got your radio on your little desk, this could be a huge advantage environmentally, not just in terms of the number of boxes that you need, but and the cost. But
yeah, I went and ran some numbers about if you ran a contest with this versus a typical station, how much money you'd save. And I think for most people, unless you live in, I don't know, California or something, it's probably not going to make a big difference because electricity is pretty cheap. Now, I know it's about 3 times in California what it is in Texas, but I don't know. You'd have to run the numbers on it, but you will also save money in electricity doing it.
I'm thinking more just the noise and heat generated. If the that would be a kind of a real plus.
Oh yeah.
I'm assuming that you've got all of the bells and whistles on the back that you have on a normal Flex, like the transverter ports and the receive ports, and it is basically an 8600, but it's got a 500 watt amplifier in it. Is that a correct statement?
I've been told by the sales and marketing team not to make that direct comparison. But Kyle, you are very correct in your assumption.
All right, we'll go
I
with
didn't
that.
say that.
From a customer understanding point of view, I think it's a really good point.
I think you're going to get that question at Dayton, so I'm glad you asked it.
I'm
Sure.
sure.
It's a
I did
500 watt
this,
radio
but-
with an internal power supply. That's there's
Yeah,
your
there you
line.
go.
Hey, I can see Jason going to switch out his remote down in Costa Rica.
Oh yeah.
Where's your
I don't think we've got an antenna down there that'll handle 500 watts at the moment, but
well, that's
can change
fixable.
we can change that.
I talked to a guy last week and has got a remote station in the desert, and they have a node red flow that checks the temperature, and they'll turn an air conditioner on and off because
yeah.
the radio generates
Oh, yeah.
heat along with the amplifier. And so this is, that's a pretty novel idea. Is now you have to run the air conditioner less because the radio is going to be fine, and you're still going to be able to get 500 watts. Is generally what that's enough for a lot of people. So that's pretty cool. I think you got a number of remote people that are going to be really happy with that.
We did.
Yeah.
Well, and then the remote thing too. I mean, space is always a premium.
Yep.
You have a big rack full of stuff is a pain.
Right.
If you can stuff it all into one case, that's great.
We did bring forward the temperature measurement inside the radio to the front panel. So there is a new, actually, I may have a picture of it. Let me see if I can find this real quick. But there's a new control that shows you what the temperature and the efficiency of the radio is. And when I did the brick on key test, the heatsink didn't get over 40 degrees C.
Wow.
Here we go.
And I'm assuming you guys are going to support adaptive pre-distortion on this radio whenever software updates come out.
This radio will ship with adaptive pre-distortion running.
Ah, there you go. Nice.
It's actually important for this technology to have that. So
Gotcha.
we made it a
And-
requirement.
And GPS DO included?
Well, it'll have a GNSS receiver.
Okay.
It won't have the disciplined oscillator, but we do use that as the base and all the other kind of stuff. So yeah,
Oh, so that'll be optional.
the GPS DO is an option.
Gotcha. Okay.
Sorry, it's like an 8000, but it's not. Remember, just like they said.
Yeah,
There's
right.
There's another slide, another image you can share there, Mike, when it shows up.
Where I just have to push buttons and see which one I get. Just a second.
And just real quick, all two models, the 510 and the 520, are all full duplex?
Oh, look at that.
Yes, they're full duplex. Now, if you've worked with our radios much, you know that with a 8400 full duplex doesn't really get you SO2R because you can't listen to So, but
it only has
it
one
is full
SCU.
duplex. Yes, it has one SCU.
Okay.
Now, if you had a Mike,
I didn't pay him to say that because he and I were arguing about this last week.
yeah.
So go ahead.
So
Steve.
show the slide again, Mike.
Oh, sorry. Remove from stage. Hang on. The preview isn't loading, so I can't see which one I'm loading. There you go. Yeah.
You got it. Yeah.
Yeah. So you can see that we need to make some changes to some of this software. But in this particular case, the efficiency was not 100. It was probably 90, but the meter wasn't reading right. But there's our temperature gauge. And when I did and this is in centigrade, which we'll also have to change, make it so you can see that. But it didn't make it above 40 C with a brick on the key for 2 hours. And we were running something over 500. This says 600.
I was going to say, you're running a little hot there. You're getting 600 watts output.
I think it was 550 or so is where we actually were. And that meter needs calibration as well. So this is pretty early unit when I take this picture, but yeah.
You're telling me there's a restrictor plate in this thing. If I remove the restrictor plate, I get a couple 50 extra horsepower.
Little green wire.
Yeah.
That's where the
Well,
green wire went. That's right,
everyone in NASCAR cheats anyway, so you might
That's
as well
right.
just-
Yeah.
Wow, this
All
is
right,
really
that's good.
cool.
Cool stuff. Yeah, totally.
This is really
Pretty-
neat.
pretty neat.
Now I have a path to replace my 6700.
Mm-hmm. Yeah, I
And
got to
you can't tell Ward about it until Friday, okay?
Yeah, my lips are sealed. Sorry, Ward.
Did you even get the other one out of the box yet, Kyle?
It is. We have both flexes up at the contest
I
station.
know you do. I'm
We
just
are
kidding.
rocking and rolling. I was just
Any other
waiting.
questions for Steve?
I was just waiting for the time to pull the trigger to replace the 6700. So it looks like I'm doing it at the end of this year.
So this is really remarkable. I mean, it seems it's kind of like a step function in the core technology in transmitters, and it's kind of like reminds me of the old days when we went from linear power supplies to switching supplies, and people were like, "What's that?" And then you realize that, well, gee, this is way better for most things, and then now, nobody uses a linear supply anymore. So, Steve, do you see this kind of technology as sort of fundamental change in the marketplace in the future?
I really do, and we have had so much interest from not just the ham radio market, but other markets that we've shown this to, and it's going to make a huge difference in I think a lot of different things. And when we went and showed the 6700 at Dayton, one of the other, which was in 2011 or 12, I can't remember, but one of the other radio manufacturers came to the booth and said, and one of our guys overheard him say, "We are so far behind." And this is what we think is going to happen at Dayton again, is folks are going to come over and go, "Oh my gosh, we got to catch up." But this technology, frankly, is more difficult than direct sampling was in 2011. There's a lot of stuff that goes into it, surprisingly. So we'll see how quickly anybody can catch up.
Nice.
I imagine this sort of thing too is like, if you could make it work once is one thing, but making it work reliably in a bunch of range of conditions and efficiently and all that must be really. I mean, I could see why it would have taken you several years to take the idea and get it to the point where it's saleable.
Yeah. We went through a lot of transistors
and dummy loads maybe.
Steve, as I've said to Mike a couple of times, it would be great if something like the 1500 would come out again. And wouldn't it be cool to have something small with all of this stuff in it, and for us low power guys?
Gee, I've never thought of that.
Yeah, just think
Awesome.
500 watts out, scale it down to just.
These guys have all heard this.
So I actually have a variation of that on that topic. Given that the 500 watt amplifier is AC only, and presumably one of the reasons is that you need a fairly high voltage for maximum power. If you're running lower power, let's say a 50 or 100 watt max in this kind of a architecture, does that mean that potentially something could be built that runs off of DC efficiently?
Absolutely, yeah. Yeah, it's just the high voltage that requires us to do that. And we could ask somebody for I think we're currently running at 96 volts internally is our highest voltage, and we could ask people for 96 DC, but nobody's going to give you that. So
that's pretty slick, guys. Thanks for
sharing.
sharing.
Yeah, very. It's remarkable.
It's going to be interesting to watch people at the booth crowd around and actually be like, "What's going on here?"
Yeah.
So,
yeah.
I must set up some secret mics around the booth and just record, put up some dummy cameras that don't look like cameras, and just record people and their responses to it. I think you'll get a kick out of that. It'll be funny. Yeah,
I'm real curious that people think that we're not really doing it too, but we brought a LP 100 power meter, so we're going to put that on it to show the power output, and we're bringing 3 infrared temperature measurement devices, as well as 2 infrared cameras that will let people walk around and look at stuff and kind of.
Are you going to bring the brick?
I was going to ask.
Yeah, bring the brick.
Oh yeah, we're bringing a very nice piece of polished wood with an old time CW key and a brick. Yes, we are doing that. We were thinking about bringing a chef and a frying pan and let him cook eggs on the we thought that would be too much.
Well, congratulations on the effort finally coming to market. It's really it sounds like a game-changing technology. So that's really amazing.
Yeah,
we're really excited about it. We're glad to share it with you. Thanks for being here.
It's revolutionary.
Absolutely.
Yeah.
Yeah. Thank you for the invite.
Yes.
You're welcome.